basically we need three kinds of data set. One is training data set, and one is validation data set, and another one is test data set. If they if we, it means if we are developing our own model, so we need to maintain this. But what mostly people are doing is they maintain this too, and they make it as a feature value, something like this. So this is with 80% of data, so this is with 20% of data while training, and they take so they take text as a feature data. This is not at all given, means there is no information for training with respect to test. So test is comes after training done. So but for training we require 80% of data of training data set and 20% of validation data set. What happens here? So while training, so the training uses this training data set of 80%, and after 80% of training data set, it learns something, right? It learns something. So whatever it learn, it is going to apply on this 20% of validation data set. Now, based on applying the 20% validation data set, so then it will see the loss. After seeing a loss, then it try to update the values. Means I try to update their weights, so their weights and their values to improve the accuracy. So this is for that purpose, to for training purpose or to for updating purpose, this validation of 20% is required with respect to each training or each training. What is the score we are getting? So can we further improve or not? So here you can see that information. Yeah, here you can see while training this epoch 1 by 8 means for epoch 1. So this is the loss at 0.6 and accuracy of 0.79 with respect to training data. And this is validation loss 0.39 and 0.86. So but this validation loss means this validation so whenever the model is training for second time in epoch 2, it will try to compute the loss based on the validation data set, means validation loss. So then again it try to improve the weights in a such a way that it will reduce the loss, or it try to improve the it try to learn the weights to improve the accuracy here as well as loss accuracy also. So this is the main purpose. So that is the main purpose. That's why means most of the means mainly we need a training data set and validation data set and test data set. So for the data set, so here in this competition they are not provided, means they didn't provided any information about the validation data set. So that's what I did is I just take the test data set, sorry, training data set. I split the training data set into the 80% of data in training data set as a training data set. Means here whatever they are provided as a training data set, 80% is training, and remaining 20% is validation purpose during my training. Okay, so this is what I am doing here. Okay, now here one more important point. So whenever you want to specify the so this batch size is every time what is the batch of the data we need to load, and what is the image size. Image size is very important. Whenever you are specifying an image size, you need to take care whether your pre-trained model is compatible with that image size or not. So that is very important. So here that information you can see here in this EfficientNet B3. So this EfficientNet B3 ranges the image input from 224 to 600. Actually this is information is provided in this research paper. So here you can see, but I'm not going to, like, I know the values, so that's what I make a note of it. I know because I just read, that's what I know. So here this is the research paper they published in ICML, International Conference on Machine Learning. So in this paper they mention for their each variance, what is the input shape, what is the input shape size. Okay, so we need to make sure that. So here I'm just making image size of 512, which is required for our B3 model. Okay, yeah. Here so now after that I'm going to prepare my data sets. Like here I'm going to prepare the data sets from the files. Now I'm going to here this I'm going I wrote one function. In this function I will give my path of that image and along with a label. So what is it's trying to do is it's trying to read the image and get the information in the image and try to decode the image values and get the image information in terms of numbers and along with label. Okay, so now we will see that. Okay, now here you can see. Now I'm just doing shuffling. So shuffling basically we are learning with respect to these images, right? So here you can see everything. So here there is means everything with a sequential way. So that's what I want to shuffle. Shuffle is something. See, if you place the image something like this. So if you place class one image serial, so class two image something like this. So the model is not able to means the model is not trained well if you place something like this, because it's try to remember if something comes here then second one is something probably in the class three. But if you place randomly like shuffle, like this is the first class image and this is second class image and this is again first class image and this is third class image, so something like this, then only it efficiently learn about with respect to each image. So in this case, is blindly say, hey, if something comes after first image, so then the second is image should be one. Something blindly learned. But if you shuffle the input and if you shuffle the data, then it is not. There is no chances for that kind of learning to the model. Okay, so we need to take care of that. Okay. Yeah. Now I'm just trying to load my images here. Now now I am doing some data augmentation. Like data augmentation process allows to train the model and to see how to see a single image with different properties. Like here I'm randomly cropping, randomly slip, and random means I'm rotating the image and I'm zooming also, and I'm doing some contrast. Like in image we have a contrast white black and things, right? So I'm just doing this data augmentation. I'm going to make this thing as a one layer in my model, so then each image can be seen in this many view, means this many ways. Okay, now let's see one image how it is looks like. So here this is our image. Okay, here you can see the image and this is how the image looks like. So here I think this image is somewhat healthy or yeah, I don't know as of now. Only this is the image, so there is no label. So yeah, here you can see that. So now let's see the image and with respect to data how it is. So here, the same image can, so this is the image, right? The same image is going to view with different ways. Like here you can see, this is the original image. But what this data augmentation is doing, so it try to replicate the same image with different views. Here I'm saying, I'm showing something I rotated here like this, like this, and some zooming also I did, some left rotation, right rotation, and zooming, zoom out, and making. So here you can see some contracts also there, like some brightness, like they are giving some more color to the image. These are called as a data augmentation, basically. Okay, so this is the way how a real time we can do the data augmentation, and this is useful whenever you have a less data. Whenever you have a less data, so this may be useful for you. Okay. Now let's see building a model. So now we are using pre-training, right? So first we need our pre-trained model. So here you can see this is our pre-trained model. So but so actually this pre-trained model is saved here, and I'm just taking the saved weights actually. So these weights are published. So I'm taking the weights, nothing but the features, right? So these features are published, so we can get the features. I think here in paper with code, you can see that information. Papers with code. There you can see what are the pre-trained weights we can get. Okay, so yeah, efficient. Yeah, actually, they are published. The weights are published. I mean, the features, those features are published. So what I'm trying to do, I'm trying to take that feature, and I'm trying to features means whatever that EfficientNet learn on ImageNet. So whatever the EfficientNet learn on ImageNet features. So I'm going to load the weights, which means I'm going to load the features here, and along with that I'm going to remove the final layer basically. So what it is trying to say in real time. So I will see. So so what happens, we have kind of neural network is there, some complex neural network is there in EfficientNet, and there is a final output layer. So whatever the model we want, so but by the end of the model we need to have the final output layer, because we are develop the model on ImageNet. ImageNet is containing 1,000 classes. So this output layer contains 1,000 classes. So in this 1,000 classes, uh, this EfficientNet will tells for each input what is the class. So with respect to each input, what is the class we can get. So this information we can. So this is what this EfficientNet is learning while training the data with EfficientNet. So this is what it is learned. So what I'm doing, I'm going to remove this part, and I'm going to remove this part. I just want these features only. So that's what I'm doing here. So I'm taking the weights, but I'm doing this one more thing also called include top, which means include the output layer is equal to false, which means I'm going to exclude this output layer. So then I'm going to add my own output layer on top of by using this. So then I'm going to pick this and add if I want some more layers, I can add my own some more layers, like one convolution or one kind of pooling or fully connected layers. After adding all layers, then I'm going to add my final output layer. So this is in this final output layer, I'm going to have 5 classes. So, but if I want to add this final output layer, I need to remove the output layer from this EfficientNet, because if you have that information, then there is no, it will try to, it is not useful. So that's what we want, only the features, learn features in the EfficientNet, means weights, features in nothing but weights with numbers, we can say the weights. So then that value is only required. So for that we are saying like, okay, I need a weights only, and I don't want the output top layer, and I need means I need a model with a input shape should be compatible with my shape. Like here I'm specifying the input shape. So here I already given the input shape values, like how my input
Sir,
shape
sorry
and things.
to disturb you.
Yeah. So
Sorry
here,
to interrupt.
okay.
Can you just come again, sir? That output layer, you like how to add extra layers in before the output layer. That point, can you just repeat?
Yeah, so here, see, just leave this transfer learning and leave everything. So just take as a So you want to build one model on top of EfficientNet. If you want to build on top of EfficientNet, you want to build one model actually, and in on top of on top of ImageNet dataset. And in this ImageNet dataset, you have 1,000 classes. Okay, this is present inside the ImageNet dataset. Okay, now I want to build a model. That model is able to classify the 1,000 classes. Okay, now I will do my own work and I try to find the model called EfficientNet. So these people who are find the EfficientNet, they figure out the EfficientNet model architecture, and they added so many layers and so many complex. I mean, they added the all number of layers required in their model. But so whatever the layers they can add, but by the end, we need output layer should be must be 100 fully connected output layer must with the 1,000 classes. So this is required. So whatever we learn, so till here, everything the layer is try to learn the features. So in the output layer, with respect to whatever it learns the feature, so based on the input, so it will try to see which features are going to compatible with this input. So based on that information, it's going to say out of 10, out of 1,000 classes, what is the class? Something like this. So it's something like this, the distribution. So with respect to only the solution with respect to ImageNet and 1,000 classes and EfficientNet model. Is that clear for you? Yeah. Is that clear? I think it is clear.
Yes, sir.
Now, yeah.
Yes.
Now let's use the transfer learning. How I'm going to customize this. Now let discuss about our task. So we have our own data set. So the data set is provided by the organizers, but this is our own data set, we can say. So yeah, the data set we have, and in our data set, we have a 5 classes. Okay, now what I want to do, what I am doing here is, so I'm going to use the feature representation, means the features, whatever the features learned in EfficientNet, I want to use the features learned in EfficientNet. So EfficientNet architecture containing something like this. Till now, till the last layer, it will consisting all the information about the features. In the last layer only, we have a output layer. So this output layer determines the number of classes. So what I want, but I have my own output layer, means I have my own classes. What I want to use the EfficientNet till the layer before the output layer. I want to take all the architecture till the before output layer. Okay, so that's what I want to. I'm going to take. So till output layer, then I'm going to pick the layer and place here. Okay, so my feature extraction layer is done. Now if I want, it is not mandatory. If I want to add some more layers, like some more my own layers, like convolution layer or max pooling or fully connected layers, I can add. But if I don't want any layer, I can just simply want to utilize the EfficientNet feature extraction and add my own output layer. So I can add my, means I can add, if I want to add, I can add the layers here. If I don't want, I can remove, and I need to only add the output layer with my 5 classes. So replacing the original output layer of EfficientNet with our output layer, means EfficientNet of 1,000 classes, I am going to replace with my 5 classes, the output layer. So then only whatever the features are there. So till now with respect to features only, but in the output layers, whenever any input is come, then based on the features, it will going to map the output one of the class. So if you are looking for 5 classes, you need to have only 5 classes. So that's what. If you are looking for 1,000 classes, you need to have 1,000 classes output layer. In my case, I want 5 classes. That's what I want. First, I want to remove the 1,000 classes of EfficientNet, which is on ImageNet. So I want to remove this output layer, take the EfficientNet, and I will add my own output layer with 5 classes. So that is what I am saying. Is that clear now, madam?
Yes, sir. But I have one more doubt. Can I ask,
Okay.
sir?
Yeah. Yes.
Okay. If we use this transfer learning, like
Mhm.
they must have used some different data set with number of categories different or images different. So
Yes.
if we use like here, we in ImageNet the data set what was used was completely different. Here we are using some other leaves
Yeah.
data set.
Yeah.
So
And one
how
more.
those weights and
Yeah.
all will be able to recognize, okay, this is the class which it belongs to. How it will categorize that?
Yeah. If you see the ImageNet, I think you can see some answer. ImageNet is not about ImageNet can contain information about leaves also. That's why ImageNet is very powerful. Means most of the people are using as a benchmark as ImageNet. So here, if you see, you can see the some images of leaves also. This is just a very simple picture which tells what are the classes we have, means what are the images we have in ImageNet. So in this section, you can see this. You can see there are some classes with respect to images, means plants also, plants and leaves also.
Okay, sir. And one more thing is before the output layer, if we add more layers like convolution layer or
Yeah,
pooling
we can
layer,
add. Uh-huh.
because of that efficient net be changed, the weights will not change.
No, the efficient net means that will helps to learn more. See, that will
Okay.
help you learn more. Not it is not degrade the performance of efficient net. It will the efficient net performance is still we have. If you add more layers, then it will try to increase the it try to learn more. Like we need to we want to learn more with our own layers also along with efficient net.
The complexity will be more, no, sir, then.
Yeah, complexity
If you
more. We are adding more complexity.
okay.
Yeah,
Okay,
and
sir, thank
complexity. Yeah, and one more thing, complexity completely depends on your data. So based on your data, you need to add the complexity. For example, I have only 2 classes. I need to classify only 2 classes. Then normal complexity is enough. But if I have a 10 classes and all classes are very near, then I need a good complex model. Yeah, complexity is completely based on situation to situation. So complexity we need to control and we need to take care. So if you give more complexity for simple use cases, then we are going to see the problem of overfitting.
you. Yes, sir, understood.
Yeah. Yes. Yeah. So here we are taking the weights, and then we are going to make the output layer as a false. We are reading with input as a shape, which is equivalent to our reading data set. We need to make sure. And dropped out rate is it is like a regression, regularization. How much dropped out we need to take care. Okay. Now this is ready. Now I'm going to I think I'm listening some voice. Please mute yourself. Yeah. Yeah. So here, so this is just a one layer actually. Now let's see our. So now now just forgot about this thing. So now let's see freshly about our model building. So here our model building starts. So now what we are doing is first layer is the input layer. So whatever we have, first layer is our input layer where we are reading our image, like what is the size we are mentioned, we need what is the input size we are mentioning here. So we are going to read our image with the input size, like 5112 cross 5112 cross 3. Okay, this is input layer. So after input layer we need to add all layers, And after all layers, this is feature extraction layers, then we need to add a final output layer. So this is a basic structure. This is a basic, very basic and standard structure of any neural network architecture. Okay. So similarly here also in my first, so the first I'm going to add my input layer. Then I'm going to, after adding input layer, I'm going to add the data augmentation layers, because I want to see my because my data set is not more enough to get the data. Like here you can see only with respect to class 4 we have only 2000, and here we have only 1000 samples. So those are not very good enough. At least we need to have a more data, then only machine learning works very well. So for that we are adding the data augmentation layer. So the data augmentation layer will, for each input, it will provide the data with different aspects. Now after data augmentation layer, I'm going to add the efficient net as a layer here. Here you can see. So whatever we read, no? So whatever we read, so here, yeah, here. So basically this is the one layer actually. So this layer we are preparing that the layer here. So that layer is going to added here. So here you can see the layer is added. After that layer, I am going to add the max pool layer, max global average pooling 2D layer. Then after that, I am going to add a dropout. So dropout is to take care the regularization, which means to avoid the overfitting problem and to get the good generalization error. Okay. Now after that, I'm going to have the my final output layer. In my final output layer, we need a dense layer, and dense layer with a length means that number of classes we required. So we required 5 classes. So that's what I am means we have a 5 classes. So if you see the length, then you can see the number 5, which means we have 5 classes, and I'm using this activation function as a softmax. So this is my output layer. So here you can see now I'm building my model with input as a input layer, and with output as a output layer. So here the output layer is built something like this. So finally I made my model. So here you can see with summary. So this is the input layer, sequence layer. This is functional layer called our efficient net. Efficient net. Here you can see the number of parameters in efficient net. So it's like one crore parameters are there, like 10 million parameters are there. Now after that 2D, and after that dense layer. So this is the our architecture of our model, means this is our our own model. So yeah, here you can see that summary, in summary, and here in total parameters you can see that information. Okay. Now after that I'm going to do some normalization in the layers of efficient net. So then only I'm going to get a good accuracy. Okay. Now I'm going to build now I'm going to make my callbacks and as well as my compilation. So here I'm going to use the callbacks, and along with the callbacks I want to pick the best model. During the training I want to pick the best model, and for the best model I monitor on validation loss. What is the validation loss? Based on the validation loss, whenever I got a best, means very less or good loss, or very good loss, then I'm going to save the model. uh, and so this callback is useful for that purpose. And I'm going to compile my model with loss is equal to first means categorical cross entropy loss, and I'm going to use my optimizer as an automatic optimizer. And there is a one more delay steps also I'm using. It is also a parameter. So I'm going to add all parameters required. Now I'm going to start my training. So here model dot fit, and this is with respect to our training data set, means training data, and this is the epochs, number of epochs we want, and this is our training validation data, and this is our callbacks. So if you run this, then I will run this, but it is not going to execute, means it is taking so much of time. You can see that. So here you can see slowly, like here you can it is saying estimating like 18 minutes for one epoch, but it is taking around 20 minutes for one epoch. So we have only 10 minutes left. Okay. So I'm not able to get, which I'm not able to run as of now in front of you. But I already I already run this model. Okay. Yeah. Just give a minute. Uh, yeah, here. So we means I already did the training actually. So I did the training as well as I saved the model also. Here you can see. Here you can see the model. This is the best model. So I again re-uploaded model here. So by that way I can load here. So here I just did that. So I'm just stopped actually. So that's what you can see this error. So here I save the model dot save best model dot h5. So here this is the that model here. So I re-uploaded here. Now here you can see the with respect to loss, you can see the graph how the loss is varies, and here you can see. So still the model is in good good, it is not overfitted, so you need to take care. By using these plots you can say if the model is overfit. By using this plot is it is very easy to understand. Like normally what happens, if the model is underfit, so the graph is something like this. If the model is best fit only, the graph is something like this. The model is overfit, the graph is something like this. And means the first one, the down line is represents the training loss, and upper line is represents the test validation loss. Okay, so we at one point it is again try to increase, the loss is again try to increase. So this is called as overfitting, this is good fitting, and this is underfitting till we need to train or we need to give a more complexity here. So our graph seems to be in this category and it is good fitting only. So I can conclude it as a good fitting. Now I just again going to load my weights to do the prediction on the test data. So here I am doing that. So here you can see. So basically it is already present here. So that's what I load the weights. So now I'm going to do the prediction on my test data set. So here you can see that. So I wrote one function. This function, in this function, if I give the path, this function will read the path and read the file and convert the file to numpy, which means in number, and finally ready for our prediction. And here you can see the samples. So this is the so this is for viewing the samples. This function is for viewing the samples. So here you can see the samples, different samples and test data set, like, as well as a trained data set. So now I'm going to apply the same augmentation whatever we use in our training. So like it is not same. So here also I'm going to use the augmentation layer. So now let's see the prediction and votes. Okay, so I made one more function. In this function, I'm going to take the image and convert the image to numpy array and predict model on that image and get the class of the model. Okay, so that is the purpose of this function. So okay, I think localization. Yeah. So here you can see that. So finally we are going to run this. I think it is taking. It is also taking time. Or okay, it is also taking time. So here you can see 24, 27, 30, but we are having 4,280. Okay, so finally the results is something like this. So after that, we can see the final result here. So this is the confusion matrix. So yesterday I already explained you, right? So this is with respect to ground truth, and this is with respect to prediction. So here you can see how much percentage of data is predicted correctly. So at this time I didn't use the values, but here I use the percentage. So here, for example, this 3. So whenever the class is 3, it is predicted 3 or 3 as 3 for 95 percentage, and for 0, it is predicted as 85 percentage, predicted as 0, something like that. So here the final output, here you can see. Basically, I'm not able to I'm not able to show you very in a very live manner, because here I'm facing kind of uh, I need to wait here until it is complete. But the overall is what happening is here you can see. So after our prediction done on complete our test data, here you can see the information, and finally I'm going to generate my data set, and this is my final data set. Here this is my final submission data set, where we are going to have an image and their respective labels. Okay, so this is our final submission data set. Here you can see that whatever the images we have in our test data set, so for those images only one image is there. So yeah, so for this image, uh, whatever the image is present here, so here you can see the label, means prediction. So here you can see the label 4, which means I think it is healthy. So the label is healthy. So here you can see in the image also. I think I need to download it and show you whether it is healthy image or not. Yeah. Yes. So here you can see that image. We can see that image, and as a human beings, we can means we are not expert, farmers expert who can say the label, but at least we can, based on our knowledge, we can see and we can say whether the label is correct or not. So the leaf seems to be healthy. So the prediction is 4, which means the 4 is healthy. So correct. So whatever the model predicted, so it is correct only. So based on the training tested data set. So here you can see the leaf. So it is healthy only. There is no images. There is no disease on the leaf. So this is how transfer learning works. Okay. So anyone has any questions and doubts regarding this? I'm going to provide the code. I will try to update with the organizers. So then I'm going to give you these weights also. Uh, Actually, still I think it is running still. So yeah, here you can see it is still taking. It needs 20 minutes to complete this. Means here this is like we are doing prediction only. That is not a very not a very point. Like this is just a prediction on validation data set, and with respect to validation data set, here we can see the confusion matrix. And after confusion matrix, we will test on our test data set. Basically in test data set, in test images, we are having only one image. So that's what we can see, the only one image, and label is equal to 4. And even if you see manually also, we can say it is 4 only, like healthy only. So yeah, so this is all about today's session. I hope everyone at least got a clear idea about what is the transfer learning and how the transfer learning works and what are the pre-training models, what is a pre-training model and how to use the pre-training model in our own case, in our own use case, our own project, our own problem, which is similar with our pre-trained model. Like it is means similar with the pre-trained model means so these things are I'm expecting every audience must understanding these things. So I hope that all are clear with these points. So if anyone has any doubt, please raise hand and please let me know. I'm happy to answer these questions.
Sir, when we consider epochs, on an
Mhm.
average, how many epochs we should consider to reduce the
Epoch,
loss
yeah,
for
epoxy.
accuracy?
Yeah, epoxy is something like a hyperparameter value only. Like if you consider more number of epochs, that means you are training more and you are trying to overfit the model, something like this. If you consider less number of epochs, then you need to you still need to learn something like this underfitting. So this considering epochs is based on after if we means after the training is done. So if you visualize the training history, then whether the at which epoch we are going to get the best value. See, for example, uh, see, for example, I consider the epochs is equal to 100, but what happens at something like this? It is coming something like this, but it is around 100, but here somewhere around 45 epoch something happening like this. So here you can see. So till now everything is fine, but from this epoch it is going to overfitting. So now, based on this history, based on this knowledge, and we can stop. We can go next time. We are going to run. We are going to train our model with 45, with size 45. Means with value 45 epochs. So then, at least we will means by using this information, we can control the overfitting and we can get a good epochs. Means good number for epoch. Yeah, you got it.
Yes,
What
sir.
I'm saying. Yeah. This is
Yeah,
the way
great,
actually.
great.
This is very practical way. So basically, we in the industry we are doing something like that only. So based on this visualization only, we will conclude whether it is overfit, underfit, stay at what epoch we can stop or something like that.
If data is other than CSV files, sir, like suppose if I want to consider a video would be converted to frames, and that like
Yes.
I want to just try, this video classification
Mhm.
using any model. So,
Yes.
like, can you just give a brief idea how to proceed with that, sir?
So you need a requirement of what is the activity they are doing in the video, right?
Yes, yes.
Yeah. So basically, that is a so for see similarly we are doing image classification. So similarly, whatever you are asking, there is a kind of solutions are there. Video activities. So here you can see video activity, video analysis, or video activity something. Yeah, video understanding or something. So first you need to find the data sets and you need to find the uh, uh, pre-trained models on that activity.
So actually, the problem what I'm facing is like when I just try, I get multiple codes. So I'm just getting confused, like what to use, which to use, like what next. So like finally, I'm ending up with nothing.
Yeah,
So
can you
like
please
is
can you please share your means can you please share your complete detailed information with my mail ID, so then I try to help you after doing my work, means after doing my own kind of work, so then I can give you more exact information. rather than
Sure,
with
sir.
single
Can
words.
you just please give your mail ID, sir, so that I can just mail you?
Yeah, I will put in a WhatsApp group. So then you can means I will inform my mail ID to the organizer. Then they will put in a WhatsApp group. Then you can just
Sure, sir.
send
Thank
me the complete details instead of even I'm also like we are not get the complete details now. Like with only words is not useful. So that's what I'm feeling.
you. Yeah,
Yeah, but
yes, sure, sir.
whatever you are asked, like whatever you are targeting, I clear. Like what is the project the problem statement you have? I have a clear idea, but still I want to get more information from you. So then that is helpful for me to help you.
Sure, sir.
Yeah, thank you.
Thank
And
you.
still anyone has any doubt? Otherwise, we can conclude the session. Like, if anyone has any doubt, please raise your hands and please proceed.
Sir, little about the deployment.
Okay. Deployment is something. It is completely based on your use case, whether you want in cloud or you want within your promises, like within your office or within if it is within your office means in a system, in a standalone system, you need to deploy in your system. Like within the system, you can run the every day. You need every time you can run the application based on your use case, basically.
Okay.
For
So something
cloud,
like
Google
Mhm.
Cloud, Google
Right.
Cloud platform, where we can host deep learning models, basically. And for study purpose, for student purpose, we have a Heroku, where we can deploy the cloud, and Amazon Cloud, I mean Amazon AWS also there. There also we can deploy it, and you can find some initial documents like introduction documents, how to deploy the deep learning on clouds. You can find there in with respect to each platform. You can find each documentation. Go with the documentation and means just it's like a step by step process. Like and take the steps and upload it and make sure the steps are in a properly. So then that is a way to that is a available ways.
Right. Sure, sir. Thank you.
Yeah, thank you.
So I just missed about your inductions at the beginning. Can you let us know? I mean, your qualification or the present working and all. I just missed up.
What you I mean, sir? Can you please repeat again? What you're missing?
About your educational qualification or the just induction. I just missed your induction yesterday in the morning session and
Okay.
the first.
Yeah. Myself, Sai Kumar Dandla, a research scientist in Amazon AA, and previously worked as a scientist in DRDO.
Oh,
And I did
hmm.
bachelor's in computer science from JNTU Hyderabad. So I'm coming from means I'm I belongs to Telangana. So that is a short introduction.
Great, sir.
Yeah.
Good. Thank you.
Yeah. Thank you, everyone.
Okay, so this is today we are going to conclude our 5 day long workshops or short term course in AIML.
Sir,
So,
before that, sir,
yes, sir.
sorry for interrupt.
Yes, sir.
So,
Yes, sir. Sure, sure.
yeah, thank you everyone. So, thanks for 2 days kind coordination. I'm feeling very like this team is completely good. I feel very happy for the sessions. So, if you need anything, I will try to you can try to send your information through my mail ID. I will definitely give a mail ID through the organizers, and I'm going to hand over the session to the organizers. Thank you all.
So please
Thank you,
provide
Thank
sir.
you,
your
sir.
mail ID.
Thank you very
I
much.
can write you.
Yeah, sure, madam. Thank you. Definitely.
Yes, ma'am.
Yeah,
We'll
very informative
coordinate
session,
and
sir.
we'll
Thank
share all
you.
the details and previous PPTs, IPython notebooks in
Thank
the
you, sir.
WhatsApp.
So
Okay,
please share
so
recording and code so that we will be able to
yeah,
practice
actually,
whatever
ma'am,
sir
what's
has told.
happening that recording we are doing and we will share the recording, right? Each day we'll
Yeah,
share
but
the
today
previous day's
itself, if you
recording.
are, because today, sir, a kind request is that because today we heard what sir told. So if today itself, if you can share so that at least we can go through,
No, no, we will definitely
we will
share. It's been
recollect.
recorded. It's been recorded. Don't worry about that. And regarding
Okay.
that, those PPTs and IPython notebooks, that has been shared with Dr. Raju Boika, who is a coordinator for NIT Warangal. So he will definitely share those study materials. In my hand, I have these recordings. Okay, my team is recording the session, and we always share the recordings every day in the morning, because it's a large file and it take time to process. So that's why the delay. Because I have seen in
Yeah.
WhatsApp group, they always ask about share it now, yeah, these things. So that's what happens actually. So we'll definitely share
Mm.
the today's recording
Sir,
tomorrow.
A
one
recording as well as the
uh,
code also
sir,
can
one
share. We
small
will be able to
request.
track.
Right, right. Of course, of course, of course, of
Sir,
course.
one continuation of madam's request from my side, also one small request.
Hmm.
Kindly compile everything and put it as like day 1, day 2, day 2, day 3, like all these days into a one message, so that we can if
Sure, sure,
anyone
sure,
missed also
sure,
we can
sure.
take,
Of
because
course, of course.
going to the last dates and first date, it will be taking so much of time, and we may miss also. It is
Right,
kind
right,
request,
right,
you
right. I
please put
understand.
even the basic Python recordings also you were putting in the group. I saw, and even I downloaded some of the things, but somewhere I missed the track also. It is better as a whole. All these 5 days basic Python program, as well as this
Right, right.
AIML and all, you can put it as a single message. It could be better for all of us.
Right, 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 right. I'll
Please
convey
consider
Yes,
your
sir.
all.
message to Dr. Raju as
Yes.
well, and
Similarly, as well as
we'll
with
do that.
Python.
In one single message, you put all these things, sir. It
Right,
could be
right.
better, I
And
feel.
we'll send you email as well. No worries.
Yeah, that is
Okay, we
fine.
have
That is fine. That is fine. Thank you,
yeah,
sir.
we
Thank
have
you.
your
Thank you.
email IDs so that you can access that as well.
How
Okay,
long this
so
data will be available in that drive, sir? You will be
yeah, yeah.
deleting after
As
some day,
regarding
or
that, actually, as you can understand that we are sharing a Google Drive link, so it is blocking
yes.
someone's drive space. So I'll
Okay.
suggest that you download this because eventually I have to delete those because we need that drive space. So
Yeah, yeah, we are
yeah,
downloading
we
by
can keep
mistakenly.
that
If
a
we miss,
month maximum,
yeah, yeah,
not
okay,
more
that is
than
fine,
that.
sir. That is fine.
Yeah, so I'll urge everyone to download the recordings in your own systems
Definitely,
within
sir.
like a
Already
week.
we started to download, but if you tell that is up to this much day, it will be there means
Yeah,
it will
yeah,
not.
1 month max.
Okay.
Cannot extend more than that.
Okay, fine, fine.
Yeah,
Thank you,
right.
thank you.
Because we have other
Sir,
informations as well too. Yeah, yeah, yes, yes.
sir, in that form where we have to like fill out the details, it is written that we have to fill the name of the institute.
Sorry, come again. I didn't get you. What you're saying?
Sir, in the link provided in the WhatsApp group regarding the details that will be written on the certificate, there
Hmm.
is one option that we have to write the name of the institute. So, like
The
I have
institute you are
done,
related to. That means you are working or studying, something like that.
sir, like in my case, I have completed my 12th in 2021. So, I will take admission like somewhere in September intake only. So, what should I write?
So you write your previous institute. So still you are not related to any institute, right?
No, not now.
Yeah, yeah. So you write your school name then. You don't have any option,
Okay,
right? So you write your school name. That's it. So regarding the feedback, so we have a very good feedback. So you have encouraged us a lot, and I want to say 2 lines here that this is a very short-term course, and the topics are advanced. And I was going through the questions previous day. Someone was asking that CDF and PDF. So for that, bits and pieces of every subject is here, like statistics, operation research, mathematics, coding, these things. So our aim is to, trigger that curiosity in you, and those of you who are interested. Okay, so everything can be completed in these 5 days. So I hope that you have taken most of it, and after this, you need your own, encouragement and own push to learn the subject. So I want some of you to say something. Mr. Prabhakaran, you want to say something regarding the course,
Yes,
what
sir.
we have like done
First
in
of
these
all, I
five
would like
days.
to, yeah, thank you, thank you, thank you.
Mm-hmm.
Uh, First of all, I would like to thank Mr. Sai Kumar Dandla and other team members for organizing such a great training program through online. Of course, it is very difficult to even from our side to listen all these things. But anyways, today's it is almost very close to my work which
Yes,
I'm
yes,
doing
yes.
right now.
He's very
So
interactive, like this only. I
yeah,
have
and
heard
one more.
his previous session as well when he was in DRDO, you know.
Uh, no, no, sir. I am in NIOT actually. I was not in.
No, no, no. I
In
am talking about Sai Kumar Dandla. He
oh,
said, right?
sorry.
He was
Yeah,
assigned to
I was
DRDO.
telling
So
about Sai Kumar
from that
Dandla.
time,
Yes.
I know him. So that's what I'm
Yeah.
talking. Yeah.
Yeah, actually, it was a nice presentation given by him, and even this transfer learning. It is actually, I'm doing. I after I heard all this process, I started to laugh myself because I was doing almost the same thing, but I I'm not knowing that I'm doing the transfer learning.
Right.
So, anyways, it was a good class and a good session. We had almost all these 5 days, sir. Thank you very much. If any in future, if we have, please let us know so that we can try to join.
Sure,
And
sure,
even
sir.
any
Sure, sir. Sure.
advanced anything like more related to point specific technologies there means related to machine learning or artificial intelligence, deep learning, anything. Please do let us know. We will try to join in the session, sir.
Right.
Thank you very much once
Right,
again.
sir. Right, sir.
Yeah.
Yes, Mahinder ji, you have raised your hand. You want
Yeah,
to say
so
something?
thanks.
Yeah.
Yeah, so thanks for giving me an opportunity to speak, to say like a thanks words to the our tutor. So first day when we have interacted, and the first of all I would say Raju Garu sir, to it will be a very grateful things which they have given scheduled a short-term program for us for the beginners. So thanks a lot for the Prasad sirs who've been taking us into the Python programming, and Sai sir for coming to like AI and machine learning. It's a been first time I have been attended into the coding side, and today I'm taking so many things learning with me as I'm working in an investment management company. So these are the machine learnings and the Python programming I'm taking away with me to implement and to improvise my process. So thanks a lot for sharing your knowledge and the giving the case studies and the data source, how filtration and all. So thanks a lot for Prasad and Sai sir for sharing your knowledge and teaching us this code.
Right, sir. Right, sir. Next, Hifzur Rahman. You want to say something? So please
Hello,
go
sir.
ahead.
Hi, everyone.
Hello.
Sir,
Hello. Hi.
I have some questions related Python. Can I ask here or particularly message someone?
No, no, sir. Actually, you can contact the resource persons only. So we will share
Uh,
their details in the WhatsApp group as well as in the mail. So you can contact them.
Sir, can we
okay,
get
okay.
their
Thank you.
LinkedIn IDs?
Yeah, you may ask that in their mail only.
Okay.
Okay,
Okay.
okay.
Okay. So you may ask directly to them. Yeah. Okay. Mr. Panda, Devvrat Panda, are you there? Mr. Panda. Okay. Anyone else want to say something regarding the course from the participants?
It's not about the course content something. So while filling the form in the industry
Right.
specific, as I'm like a professional working in MNC, right? So I have given my designation and my company name. Is that
Hmm.
works that way?
Yeah, that's fine. That's fine. The institute
Yeah.
name is for that. The institute you are related with. If you are working
Okay.
somewhere, you will give the name of that company.
Correct. So I have selected the other and my designation and my company name both.
Right, right. That's fine. That's
Okay.
fine. That's fine.
Thanks
Yes.
for the
Yes.
confirmation.
Any other doubts regarding anything? Okay, so this is it. So this is time for vote of thanks. So it's my pleasure to propose a vote of thanks on this occasion, when our exclusive 5-day online short-term course on application of machine learning and deep learning in data science has successfully concluded. I would like to thank Honorable Director NIT Warangal, Dr. N.V. Ramana Rao, esteemed Principal, Sri Venkateshwara College, Professor Sheila Reddy, respected Vice Principal, Dr. S. Venkat Kumar, and Head of the Department of Computer Science Engineering, Department Dr. N.V. Ravichandran, and Teacher in Charge, Department of Mathematics, Sri Venkateshwara College, Dr. Deepthi Jain, for giving us this opportunity to conduct this online course. I also would like to extend my gratitude to CC in charge, Dr. Raju Bhuika, for his efforts and contribution to organize this course. I, on behalf of the Department of Mathematics, Sri Venkateswara College, University of Delhi, and Center of Continuing Education, NIT Warangal, would also like to extend a very hearty vote of thanks to all the speakers for gracing this occasion with their presence and sharing their valuable knowledge with all the participants. I would like to thank Dr. N.V. Ramana Rao, Director NIT Warangal, for his informational talk on online teaching methodologies. We are grateful to have Mr. B. Prasad, Dr. Damodar Reddy from NIT Goa, Dr. Satya from IIIT Kurnool, and Mr. Santosh Amilpur. And a very special thank to Mr. Sai Kumar Dandla from Amazon for such an interactive session. And of course, I thank my dear students, Trisectic members of Department of Mathematics, Sejal, Jaskaran, Uditi, Prerna, Rishav, and Mr. Praveen, who is a research scholar and student of Dr. Raju Buika from NIT Warangal, also worked very hard to make this event a success. And that's it. Thank you, everyone. And I thank all the participants also to register in this course and make it a success. Thank you.
Yeah, thank you, Mr. Anirban. Thank you. Thank you very much.
Thank you.
Thank you, everyone.
Okay.
Thanks for giving opportunity.
Thank
Bye.
you, sir. Thank you.